Would the alphabet go after the tridiamide?
Since these are all methyl groups for functional groups, no, you would alphabetize the names of them, not using the diatribe. But be careful on this one. I'll show you why. This one is not very nice. What is the name of the parent in this compound? How many carbons in the parent?
7.
The parent is the longest continuous chain of carbons. There are 8. Now, I told you this was not a nice one, and here's why. Because when we start, it's obvious, okay, this is going to start the parent, so we're starting here. But then when you get over to this other side, you see, okay, this carbon will just end there. But after this carbon, if you go down there, you get 2 more carbons. That is the parent. Eight carbons in the parent. Yep. So you didn't have an ethyl on there. And of course, I did this on purpose. I mean, I could have been nice and just put them all horizontally, but I do want you to see that it does not have to be a nice, even horizontal parent. It might zigzag on you, and just watch for the most continuous, the longest continuous chain. Okay, so with that identified as the parent, then we have a functional group there, there, and there. So we have to, it looks like there's 3 methyl groups on this thing. So it's going to be something trimethyl octane. Is this carbon number 1? Shake your head, yes or no. Is this carbon number 1 in the parent? Yes. This as carbon number 1 is going to make our numbers for where the locations of the functional groups are lower, minimized. So if this is carbon number 1, we're going to have a methyl group on carbon number 3. See, there's carbon number 3. It's attached to the methyl group. Carbon number 4 has a methyl group on it, and carbon number 5 has a methyl group on it. So the name of this thing, 3,4,5 trimethyl octane. I want to give you a moment to digest that. Ask if you have any questions. And please don't feel bad. Don't feel like you're slowing the class down and people are going to scowl at you. They're not going to. So once again, our parent is in red here. There's 8 in a row. That makes it octane for a parent. And then we have encircled in green are the 3 functional groups on the parent coming off of the parent chain. So if that's carbon number 1, there's 2 and there's 3. So our first methyl group is on carbon number 3. And then 1 on carbon number 4 and 1 on carbon number 5. So 3, 4, 5 trimethyl. Anything for me? Okay, let's try one more example. How many carbons in the parent this time? Yeah, 7. This one's easier to see. The challenge to this one is figuring out how to number the carbons. Okay, so we have a methyl group here and then a bromo group over there. Shake your head yes or no. Is this carbon number 1? No. This one? This one is going to make our numbers for the functional group location smaller, so that's what we're going to go with. We have, looks like 2 bromo and then 5 methyl. The rule that I gave you, I think it was on the previous slide, was if you have different functional groups, alphabetize them. I'll admit to you, the proper way is to alphabetize them, but if you identify where they are and you don't alphabetize, as long as you have them in the right place and the right number on them, I'm not going to mark you down for that. But just so you know, that is the proper way to do it. So we'll put the bromo on there first because it is first alphabetically. 2 bromo. And then we have 5 methyl. Heptane. Shall we go on? Now this slide is about when you have double or triple bonds in a compound. We call those, remember, unsaturated. They're called unsaturated because in order to get 2 carbons to make a double bond, each of them would have to give up a hydrogen that they're bonded to in order to do that. Same thing with a triple bond. Each triple bonding carbon has to give up 2 hydrogens to do that. So unsaturated just means that this thing could react, this compound could react, and add more hydrogen, more atoms on the molecule without adding more carbons. So here's more about alkenes. I had mentioned alkenes before, but an alkene has the standard formula CnH2n. Remember, it has lost 2 H's in order for the carbon to make a double bond. So when we name an alkene, we're going to change the ending. Rather than using ane at the end, like pentane or octane or whatever, we'd use ene. So if you see an ene, that means that there's a double bond in the molecule. And we have to say where it is, that matters. So we number the carbons in these 2. Here's an example. Okay, so looking at this is 3-heptene, there's 7 carbons, but there's a double bond between carbon number 3 and 4, so we just use the number 3, the lower number obviously. Is it possible to have 4-heptene? Four heptene just means taking that double bond and moving it over one. Is that right? John, why not? That's right. That would make this one carbon number 1, and it would be 3 away from that carbon if the double bond was right there. So it would still be 3-heptene. Yeah? So it's impossible. If you ever write 4-heptene, it'll be wrong. You didn't need to start numbering from the other side. That's it with the alkanes. The same thing is true for the alkynes. Alkyne means that there's a triple bond somewhere in there. And so the name of the compound would end with YNE for that. And of course, you have to identify where the triple bond is. You got one more slide in you? Do one more? Okay. Oh, and it's not going to be this one. This one is a terrible slide to do on the day before a long weekend. This is very obnoxious. Sometimes you can have such a big branch that the branch can be branched. Ugh. And we would need to know how to name those things. I'm just going to show them to you right now, but I will spend a little bit more time on them when we get back on Tuesday. I'll just rearrange these slides. Forgot that this was in the middle here. Don't write this down. This is just for your eyes. Assuming this is the parent chain over here, so the parent chain is going up and down. Off of the parent chain is a propyl group. Well, propyl means that there are 3 carbons. Boom, they're all on the line. But if you have 3